Good afternoon, students. Am I audible? Okay. So today we are going to solve numericals related to Lysis cell theory. Okay. So that theory we have already discussed in the last class. So today we are going to solve few numericals related to our Lysis cell theory as well as our Kennedy's theory. Okay, which is used for to design erodible channel, or you can say mobile boundary. Okay. So this is our first numerical. Okay. So you kindly write down the numerical question of the numerical. So what is given here? Design an irrigation canal carrying a discharge of 15 meter cube per second. Okay. The discharge is given 15 meter cube per second by Lysis silt theory. Okay. Assume that silt factor is to be 1.1. Okay. The silt factor small f is given 1.1 and provide necessary free will. So we have to design an irrigation canal for a discharge of 15 meter cube per second by Lysis silt theory. Okay, and then the silt factor is given 1.1, and we need to provide necessary freeboard. Okay, so what is freeboard? We have already discussed in the last class. Okay, so given is 15 meter cube per second discharge and silt factor is 1.1. So if you remember in the Lysis silt theory, the first step is to find out the silt factor. Okay, as in this question your silt factor is already given, so we are going to directly move to step number 2. Okay, because that silt factor is already given, so if it is already known, then we are not going to determine again. Okay, so that is why we are going to skip step number 1 and we move on to step number 2. So second step is to find out the velocity by using this equation. Qf square divided by 140 to the power 1 by 6. Okay. So you substitute the value in place of Q, it's 15, that is already given. In place of small f, you substitute 1.1, that is also given. Okay. And 140 to the power 1 by 6. Find out the velocity, how much you got. It is approximately 0.71. Okay. So you are getting the same value or not. Okay. 0.71 meter per second. Okay. So In step number 2, we calculate velocity by using this equation qf square divided by 140 to the power 1 by 6. Okay, so then we move to step number 3. Okay, in step number 3, we need to find out the cross sectional area. Okay, so we all know discharge is equal to nothing but area multiplied by velocity. Okay, so for area, we can find out divided by q divided by velocity. Okay, so that is why uh, in this step we are going to determine the area. Okay, so discharge is already known and velocity we have already calculated in step number 2. So you substitute here and see you are getting 21.13 meters square. Over. So in the next step, see the shape of the channel is not given. So we are going to consider as a trapezoidal channel. Okay, we are going to consider as a trapezoidal channel. Okay, and the side slope of the channel is not given, so we consider z is equal to 1. Okay, so always remember when z value is not given, you try to assume as 1. Okay, it will give you us it can help you in simplify the calculation. Okay, so whenever the z value is not given, you assume z is equal to 1. Okay, so in step number 4, we consider that channel is trapezoidal and the side slope we have considered is equal to 1. Okay, then what will be the area equation for trapezoidal channel? This thing we have already discussed. Okay, it's width of the channel multiplied by y plus zy square. Okay, so this is the area equation of a trapezoidal channel. In this equation, we know the area that we have already calculated, that is 21.13. Width of the channel is not known and y is also not known. Z is known to us. Okay, that is why in area, in place of area, we have substitute 21.13 is equal to by plus y square. In place of z, we have substitute 1. Okay, so that is why it is plus y square. Okay, so then we find out expression for b in terms of y. Okay, equation, from this equation, we can minus y square. Okay, so if you bring this y square in the left hand side, it will be minus, and what will be left out is b multiplied by y. So for b, nothing but 21.13 minus y square divided by y. Okay, and we can consider this is number equation number 1. Okay, okay. Then next is for weighted perimeter. Okay, weighted perimeter, we have one equation that is 4.75 root over q. Okay, for weighted perimeter we have equation 4.75 root over q. So you find out the weighted perimeter because discharge is already known to you, that is your 15 meter cube per second. Substitute here, you find out the weighted perimeter. You will get approximately 18.4 meter. Okay, so you are getting the same value or not? Okay, very good. So you are, if you are getting the same value, now we are going to proceed. Okay, so you are getting this as your weighted perimeter 18.4 meter. Now we are going to use the weighted perimeter equation of a trapezoidal channel. Okay, you remember that weighted perimeter equation for a trapezoidal channel is P is equal to P plus twice Y root over 1 plus Z square. Okay. So this is the weighted perimeter equation of a trapezoidal channel. Okay. So these things we have already discussed in many times. Okay. So you people already use this equation for calculating weighted perimeter of a rectangular channel. So this perimeter we have already calculated by using this equation, which is given by Lysis. Okay, that is P is equal to 4.75 root over Q. Okay, so that is why in this equation in place of P we are going to substitute 18.4. Okay, so is equal to width of the channel B. B is not known to us. Okay, addition twice Y root over 1 plus Z square. So Z is equal to 1 we have assumed. Okay, so that is why here 1 plus 1 square. Okay, place of Z we have substituted 1. Okay, when you come into the next line, 18.4 is equal to in place of B we have substituted this equation. This is nothing but your equation number 1. Okay, you can write here from 1, from equation number 1. Okay, so in that equation 1 we have a expression is equal to B is equal to 21.13 minus Y square divided by Y. So that is why in place of B we substitute this. Okay, and you can write here from equation number 1. Okay, so what will be left out here? In place of B we have substituted this equation, addition twice Y root over, so it will be 1 plus 1 will be 2. 1 plus 1 is equal to 2. Okay, okay. Now you do simplification. So from here with this equation, see we have only one unknown, that is Y value. Okay, if you see in that in this equation you can see we have only one unknown. Okay, that is your Y. Okay, so you can easily find out with the help of this equation what will be the Y value. So see you are getting, see, as it is a square, we are going to get a quadratic equation. Okay, so see, you are getting 2y value. So try to solve this. You can use your calculator also. With the help of calculator, you can easily find out the value of y. Okay, so you check once you are getting the same value or not. If you don't have calculator, then you can use this equation also, minus b plus minus root over b square minus 4ac by twice a. Okay, this is your 10 standard mathematics. Okay, to find out the quadratic equation. Okay, so this will take some time. If you have scientific calculator, you can directly find out the y value. Okay, okay. So see, after solving that equation, you will get two depth of flow. That is, one is 8.74 and one is 1.32. Now, you cannot design a particular canal for two depths. Okay. So, what will be your appropriate depth, or which depth you are going to select? So, that what you have to do next, you have to substitute this value of y in equation number one. Okay. In equation number one, and find out the width of the channel. Okay. Okay. So, first we have substitute the y equal to 8.74. In first case, we have substitute in place of y, we have substituted 8.74, and we are getting is minus 6.33. Okay. So this is nothing but for, you can write here for y is equal to 8.74. Okay. For y equal to 74, what will be the width of the channel is minus 6.33. Okay. Minus 6.33. Okay. So and then again you find out for y equal to 1.32 meter what will be the width of the channel, and see you are getting this or not. 14.68. Getting the same value, 14.68. Okay, so now see, one width of the channel you are getting in negative. Okay, one is in positive. So you can say, see, the width of the channel cannot be negative. Okay, width of the channel is cannot be negative. So this will be our width of the channel, and this width of the channel is for y equal to 1.32 meter. So for this channel, our depth of flow will be, or depth of the maximum depth of the canal will be 1.32 meter, and width of the canal is equal to 14.68. Okay. We can write one line, since your width of the canal cannot be negative, so we are considering the positive value. Okay, since width of the canal cannot be negative, so we are considering the positive value. Okay, and our required depth and width of the channel is 1.32 meter and 14.68 meter respectively. Okay, then our last step is to find out the slope of the channel. Okay, our last step is to find out the slope of the channel. Okay, so this is the equation for bed slope using Lysis theory. Okay, friction factor, sorry, silt factor to the power 5 by 3 divided by 3450 multiplied by q to the power 1 by 6. Okay, so use this equation and find out the bed slope. As silt factor is already given, q is also given, that is 15 meter cube per second. Okay, and see what is the value of bed slope of that particular canal. 2.16 10 to the power minus 4. It's correct. Okay. So public channel is 2.16 into 10 to the power minus 4. Okay. Okay. So in the last, we have to provide a free board. So here in Lysis theory, we are going to provide 25% of y. Okay. So y is our 1.32 meter. In that 1.32, 25% of 1.32, we are going to add extra, okay, as a free board. So the free board for that particular canal is 0.33 meter. Okay. So you last you find out the free board. Over, we are going to provide free board as a 25% of y. Okay. So if you have any doubts, you can ask me now. Okay, related to this Lysis theory. Okay. So we move on to the next numerical. Okay, this is also related to your Lysis theory. Don't worry, this the drawbacks of Lysis theory I'm going to share with you. Okay, so you need not to write now. And then after reading it, if you find that we should discuss once, then we will discuss. Okay, after completing this unit. Okay, but I think there is nothing to discuss because by simply reading you can understand what will be the drawbacks of both the method. That one is Kennedy's theory and one is Lysis cell theory. Okay, so our next numerical is also related to your Lysis theory. So here we have to design a canal. So you please write down the question. Okay, design a canal by Lysis theory for a discharge of. This is nothing but discharge. Okay, this is nothing but discharge. Okay, design a canal. Sorry, you can write also channel. Same thing. Design a channel by Lysis theory for a discharge of 40 cumex, that is 40 meter cube per second. So write down the question. Okay, this side slope may be assumed as one horizontal is to one vertical. Okay, one horizontal is to one vertical. Okay, this is nothing but your one horizontal to one vertical. Okay, the side slope. Okay, that means we are going to consider a trapezoidal channel. The side slope of the channel is one horizontal is to one vertical. The average size of the bed material, the average size of the bed material is 0.8 mm. This is nothing but your small d. Okay, small d is given 0.8 mm. Okay, it's not visible. Actually, today we have some network issue. Okay, okay, fine. Okay, so you start solving. Okay, by step you follow the steps. Okay, first, so in a previous case we have skipped the first step. In previous case we have skipped the first step because our seal factor is given. Okay, but here in this numerical our seal factor is not given. So first we need to find out the seal factor. Okay, so first step is we need to find out the seal factor. This is nothing but 1.76 to the power, sorry, multiplied by root over d. Okay, so this d is small d is nothing but your size of the bed materials in mm. Okay, so here your bed material size is given in only, so you can directly substitute here. Okay, if this bed materials is not in then you have to convert first into then only you can substitute here in this equation. Okay, always remember, first you have to convert into then only you can substitute here. So it is already in so we will directly substitute here and find out the silt factor. much you got seal factor? I think it will be 0.29. Okay. You people are getting seal factor is equal to 0.29. How much you got seal factor? Okay, it's correct. Okay. 1.57. Okay. 1.57 is the correct one. Okay. 1.57. Then you find out the velocity. Okay. Find out the velocity and see how much you got. In the same equation, Q multiplied by seal factor square divided by 140 to the power 1 by 6. 0.94 meter per second. Yes, correct. Okay. 0.94 meter per second. Okay. Then the next step is to find out the area. Okay. Then find out the area, that is Q by velocity. Velocity is already given, that is 40 per second. Discharge is given 40 meter cube per second, and velocity you have already calculated in step number 2. Okay. And see you are getting the same value or not for cross sectional area. Okay, it's correct. Okay. So you try to solve this numerical. Okay. So this meeting is going to end soon. Okay. So you try to solve this numerical. Okay. And we are going to discuss in the next class. Okay. We are going to discuss this numerical again in the next class. Okay. You try to solve. We are directly going to discuss about the answer. Okay.